syllabus. Hello everybody. This is day 75 on your syllabus. Notice the title, Trigonometric Sum and Difference Identities. Remember a sum, answer to an addition problem. Difference, answer to a subtraction problem. And then the word identities, and remember identities, you can plug in any angle you want, and it's always a true sentence. Now, the big question here at the beginning is, can you distribute a trig function like this? Is sine of 45 degrees plus 60 degrees equal to the sine of 45 degrees plus the sine of 60 degrees? Can you do this? Now, calculator, be in degree mode. Now, please notice this sentence right here. Obviously, 45 degrees plus 60 degrees is 105 degrees. But the real question is, can you distribute? So calculator, degree mode. I want you to find the sine of 105 degrees. And I want you to find the sine of 45 degrees plus 60 degrees. I'll pause while I do that myself. For sine of 105 degrees, I got 0.966. Remember, we're going to round everything to 3 decimal places. And for the sine of 45 degrees plus 60 degrees, I got 1.573. What conclusion can you reach based on the calculations above? Well, I hope that you can reach the conclusion that the sine of 105 degrees is not equal to the sine of 45 degrees plus the sine of 60 degrees. Remember, when you see the sine of, let's just do it this way, x plus y, that does not mean sine times. It means the sine of some angle, but it is not sine times an angle. That's why you can't distribute, because it's not a multiplication. There is a more detailed answer in the filled in notes that are posted. If you want to look at that, that's fine. Now, I want you to look at a formula. We're on the next piece of the notes. We're going to use this formula right here. The sine of a plus b equals the sine of a times the cosine of b plus the cosine of a times the sine of b to find the value of sine of 45 degrees plus 60 degrees. So what we've got here, we're going to let 45 degrees be a and 60 degrees be b. So the sine of 45 degrees plus 60 degrees equals sine of 45 degrees times cosine of 60 degrees plus the cosine of 45 degrees times the sine of 60 degrees. Now let me make sure I wrote that down right. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Okay. Now the thing is that you know 45 degrees and 60 degrees. So let's just do this. Sine of 45 degrees is square root 2 over 2. Cosine of 60 degrees is square root 3 over 2, plus cosine of 45 degrees is square root 2 over 2. Sine of 60 degrees is square root 3 over 2. So let's see, what does that give us? That gives us square root of 6 over 4 plus square root of 6 over 4. Hang on just a minute. Well, it will help if I do it right, won't it? I knew there was something wrong there. Let's go back right here, because the cosine of 60 degrees is not square root of 3 over 2, is it? Cosine of 60 degrees is a half. That's better. So what have I got? I've got square root of 2 over 4 plus the square root of 6 over 4. So that's the square root of 2 plus the square root of 6 over 4. Now I want you to go to your calculator and do this. Please use the fraction feature, alpha y equals. I'm going to pause while I do it. Now, you should get approximately 0.966. Look right here. They're the same. Ladies and gentlemen, this right here is the exact value of sine of 105 degrees. So we do have some formulas that will work for sum and difference identities for sine. Now let's take a look at these that are in the box. The sine of a plus b and the sine of a minus b. Now you have to learn those. You will not have a note card. Let's just practice with them. Let's see what we can do. Find the exact value of the sine of 15 degrees using two angles from the unit circle whose difference is 15 degrees. Now, the most obvious one, I think, is probably either, well, 60 minus 45, or you could do 45 minus 30. Either one is going to be fine. So I could do this. I could do sine of 60 degrees minus 45 degrees, or I could do sine of 45 degrees minus 30 degrees. Does not matter, because guess what? You're going to get the same answer. So which one am I going to pick? I'll just do sine of 45 degrees minus 30 degrees. Let me do it this way. The sine of 15 degrees equals the sine of 45 degrees minus 30 degrees. Now notice, this is a minus, okay, because it said to do a difference. So I'm going to be using this formula right here. So I'm going to let A be 45 degrees, and I'm going to let B be 30 degrees. So let's apply that formula. Equals the sine of 45 degrees times the cosine of 30 degrees minus the cosine of 30 degrees times the, oops, got that wrong. It's the sine of the first times the cosine of the second minus the cosine of the first times the sine of the second. It's easier for me if I just say it out loud what the pattern is. Now let's see if I don't mess this one up. The sine of 45 degrees is square root 2 over 2. The cosine of 30 degrees is square root 3 over 2 minus the cosine of 45 degrees is square root 2 over 2 times the sine of 30 degrees is 1/2. So what is the exact value of the sine of 15 degrees? Well, it's the square root of 6 over 4 minus the square root of 2 over 4, which we're going to write as square root of 6 minus the square root of 2 all over 4. That's the exact value of the sine of 15 degrees. Let's try another one. Find the exact value of sine of 285 degrees using two angles from the unit circle whose sum is 285 degrees. I'm going to pause for a second while I erase the other one so I'll have room. I need two angles that have a sum of 285 degrees that are actually on the unit circle. You may want to get out your unit circle so you can look for two angles that you know about that have a sum of 285 degrees. I think I'm going to go this way, 150 because I know that one, and 135, I know that one. That's 285. So let's use those two. The sine of 285 degrees is the sine, pardon that brief interruption there, sine of 285 degrees equals the sine of 150 degrees plus 135 degrees. Now, does it matter which one goes first in a sum? No, of course not. So, formula, this is a sum, so we're going to use this one. Sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. Now you'll need to do a little bit of thinking here. That's crooked, but oh well. 150 degrees. 150 degrees is in quadrant 2 with a reference angle of 30 degrees. So the sine of 150 degrees is 1/2. The cosine of 150 degrees is negative square root 3 over 2. (135 degrees is also in quadrant 2 with a reference angle of 45 degrees. The cosine of 135 degrees is negative square root 2 over 2. Let me see here. And the sine of 135 degrees is square root 2 over 2. And this is a minus, a plus. So what's our answer here? Negative square root 2 over 4 plus negative square root 6 over 4. So that gives us negative root 2 minus root 6 all over 4. And that's how you do these. That's the pattern. Next page. Okay. Simplify each of the following expressions using a sign, sum, or difference identity. Okay, so this one is sine with a plus. Now remember, sine with a plus is sine of the, let's do it this way. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. So A is going to be x, and B is going to be 2 pi over 3. So this will be sine of the first times cosine of the second plus cosine of the first, sine of the second. 2 pi over 3. Well, 2 pi over 3 is in quadrant 2 with a reference angle of pi over 3. So the cosine of 2 pi over 3, let's see here. The cosine of pi over 3 is 1/2. So in quadrant 2, that's negative 1/2. So this is sine of x times negative 1/2 plus cosine of x times the sine of 2 pi over 3 is the sine of pi over 3, which is square root 3 over 2. And in quadrant 2, that's still positive. So square root of 3 over 2. So how are we going to write our answer? Well, let's see. We could write, I'm perfectly happy if you just write this. Now again, you may have this and this switched if you, never mind, forget what I just said because the x is first and the 2 pi over 3 is second. So there's your answer right there. Let's go to the B one. Sine of pi over 2 minus theta. Sine of a minus b is the sine of the first, cosine of the second, minus cosine of the first, sine of the second. So A is pi over 2 and B is theta. So this is going to be sine of pi over 2 cosine of theta minus cosine of pi over 2 sine of theta. Well, I know the sine of pi over 2 is 1. So this is cosine theta. The cosine of pi over 2 is 0. So the sine of pi over 2 minus theta is cosine theta. That's kind of cool. Now look at these last two. If you'll notice, they go backwards. The last two here, we are given this. Oops, sorry, that's bad. we are given this, and we need to go backwards to this. Okay, so which one of those says sine of the first, cosine of the second, plus cosine of the first, sine of the second? Well, I seem to recall that sine of A plus B. So that's going to be the sine of 75 degrees plus 15 degrees. Well, what is that? Well, that's the sine of 90 degrees. Oh, that's one. That's kind of cool. Second one. Second one says the sine of the first times the cosine of the second minus the cosine of the first times the sine of the second. So that's going to be sine of A minus B. So this is going to be the sine of 290 minus 50, which is the sine of 240 degrees. Well, let's remember where 240 degrees is. 240 degrees is in quadrant 3 with a reference angle of 60 degrees. So the sine of 60 degrees is square root 3 over 2, but in quadrant 3 it's negative. So negative square root 3 over 2. We've done everything with sine. Now let's go to cosine. Cosine's formulas are similar, so you're going to have to be careful not to get them mixed up. The cosine with a plus and the cosine with a minus. Notice when it's cosine that the trig functions are the same, but the sign here is different. So let's do cosine. It says use the calculator to find the value to the nearest thousandth. So you can stop right now and figure that out real quick. Okay, well, that's pretty nice. Now let's use the sum or difference identity. Cosine with a plus is cosine of the first, cosine of the second, minus sine of the first, sine of the second. So A is pi over 6, B is pi over 2. So this is going to equal cosine of pi over 6, cosine of pi over 2, minus sine of pi over 6 times sine of pi over 2. Well, I know the cosine of pi over 2 is 0, so that makes that whole first term equal to 0. Minus the sine of pi over 6 is a half, and the sine of pi over 2 is 1. So the answer to that is negative a half. Woohoo! Same thing. Okay, cosine with a minus. The formula for cosine with a minus, is cosine of the first, cosine of the second, plus sine of the first, sine of the second. Oh, I didn't do it on the calculator. Stop a minute and do the calculator. Calculator, 0.259. Here's A. Here's B. So this is going to equal cosine of 120 degrees times the cosine of 45 degrees plus the sine of 120 degrees times the sine of 45 degrees. Okay, let's go think about 120 degrees. 120 degrees is in quadrant 2 with a reference angle of 60 degrees. The cosine of 60 degrees is 1/2. In quadrant 2 is negative, so that's negative 1/2 times the cosine of 45 degrees is square root of 2 over 2 plus the sine of 120 degrees. Well, the sine of 60 degrees is square root of 3 over 2. In quadrant 2, it's still positive. Square root of 3 over 2 times the sine of 45 degrees is square root of 2 over 2. So let's see, what do we get? We get negative square root 2 over 4 plus square root of 6 over 4, which equals negative root 2 plus root 6 all over 4. Take just a minute, put that in your calculator, make sure it equals this. Hope you're doing okay so far. Next page. Tangent. Now the tangent formulas are just a little bit different. Learn them. Tangent with a sum is tangent A plus tangent B over 1 minus tangent A times tangent B. And with a minus, tangent A minus tangent B over 1 plus tangent A times tangent B. Okay, find the exact value of tangent 75 degrees using two angles from the unit circle whose difference is 75 degrees. Okay, so I got to come up with two angles that you could subtract that I know about to give me 75 degrees. Yeah, let me see here. 120 minus 120 minus 45 work? 11. Yep. Let's do 120 minus 45. So the tangent of 75 degrees is the tangent of 120 degrees minus 45 degrees. So I'm going to be using this one. So that's equal to the tangent of 120 degrees minus the tangent of 45 degrees divided by 1 plus the tangent of 120 degrees times the tangent of 45 degrees. All right, so we know the tangent of 45 degrees is 1. So let's find the tangent of 120 degrees. Whoops, that's not what I wanted. 120 degrees is in quadrant 2, reference angle of 60 degrees. All right, the tangent of 60 degrees is the sine of 60 degrees divided by the cosine of 60 degrees. The sine of 60 degrees is root 3 over 2. The cosine of 60 degrees is a half. So the tangent is root 3. Now we're in quadrant 2 where tangent is negative. So the tangent of 120 degrees is negative square root of 3. So this is negative square root of 3 minus 1 over 1 plus negative square root of 3 times 1. So we're going to get negative square root of 3 minus 1 over 1 minus square root of 3. That's it. Next one. Find the exact value of tangent of 165 degrees using two angles from the unit circle whose sum is 165 degrees. Well, shoot, let's just use those. Those add up to 165 degrees. And I already know the stuff. Okay. So the tangent of 165 degrees is the tangent of 120 degrees plus 45 degrees. So I'm using the plus one. So this is the tangent of 120 degrees plus the tangent of 45 degrees divided by 1 minus the tangent of 120 degrees times the tangent of 45 degrees. Well, we know the tangent of 120 degrees is square root of 3. Plus the tangent of 45 degrees is 1. There we go. I made a mistake there, didn't I? Tangent of 120 degrees is negative. For some reason I lost it. Let's make sure that's right. Okay, you're having a little trouble this morning. That's a negative 2. So there it is. I apologize for my mistakes. Notice you got to be so careful because, boy, you just screw something up real fast. Okay, so we're good. Suppose sine of theta is 3/5 and sine of alpha is 5/13. Additionally, tangent of theta is positive and tangent of alpha is negative. Draw angles theta and alpha, labeling your reference triangles, and find these three things. Okay, here we go. We'll draw theta there, and we'll draw alpha there. Theta, the sine of theta is 3/5, and the tangent of theta is positive. So I have a positive sine, and I have a positive tangent, which means I'm going to have to be in quadrant 1. So here's my angle theta. Sine is 3/5, which means this has to be 4. Alpha, the sine of alpha is positive, the tangent of alpha is negative. A positive sine and a negative tangent means I'm going to be in quadrant 2. So there's alpha. And 5/13 is the sine, 5/13, which means this has to be 12. And I'm going to have to be negative because I'm going to the left. Okay, here we go. The sine of theta plus alpha. Now, sine with a plus is sine of the first, cosine of the second, plus cosine of the first, sine of the second. So the sine of theta, we're just reading these off the triangles. The sine of theta is 3/5. The cosine of alpha is negative 12/13, plus the cosine of theta is 4/5, and the sine of alpha is 5/13. Now I'm going to stop and make sure I got this right. Okay, I think I'm happy with it. So now what have we got here? Well, we've got negative 36 over, what's 13 times 5? 65, plus 20/65 equals negative 16/65. So that's the sine of theta plus alpha. I erased that. Now we'll go to the second one, which is cosine of alpha minus theta. Cosine of alpha minus theta. Now cosine with a minus, that's cosine alpha cosine theta plus sine alpha sine theta. Cosine alpha is negative 12/13. Cosine of theta is 4/5. Sine of alpha is 5/13. Sine of theta is 3/5. Again, I'm going to stop and think, make sure I did this right. Okay, so that gives me negative 48/65 plus 15/65. So what, negative 33/65. Here we go. One more. The last one is tangent of theta minus alpha. Tangent of theta minus alpha is tangent theta minus tangent alpha over 1 plus tangent theta, tangent alpha. Well, the tangent of theta is 3/4. Oops. Minus the tangent of alpha is negative 5/12 over 1 plus the tangent of theta was 3/4 and the tangent of alpha was negative 5/12. Okay, got a little work to do here. Let's see. What's that? 9/12 plus 5/12 is what? 14/12, and 14/12 is 7/6 over 1 minus 15/48. Well, 1 minus 15/48 would be 48/48 minus 15/48. I think that's 33/48. So 7/6 over 33/48. So that equals 7/6 times 48/33. What's that, 56/33? Let me stop and make sure this is right. Yep, I feel good about that one. Okay, last page. Algebraically verify that the equations below are trig identities. We're going to start on the left because we're going to use those formulas. So we're going to work on this. Now remember, I'm going to go over here. This is tangent of x plus tangent of pi over 4 over 1 plus, no, that's a minus, isn't it? 1 minus tangent x tangent pi over 4. Have I got that right? Let me stop and think for just a minute. Yep. All right, so tangent x plus tangent pi over 4 over 1 minus tangent x tangent pi over 4. All right, so that's tangent x plus 1 over 1 minus tangent x times 1. All right, we're going to change everything to sines and cosines. So this is going to be sine x over cosine x plus 1 over 1 minus sine x over cosine x. Okay, we need common denominators. And then here we'll need a common denominator. All right, so let's go up here. So the numerator gives me what? Sine x plus cosine x over cosine x, all divided by cosine x minus sine x over cosine x. Oh, there you go. Now remember, dividing by this means multiplying by its reciprocal. Those factor out. So this is sine x plus cosine x over cosine x minus sine x, and I hope that's what we were looking for. Yay. Cosine x plus sine x over cosine x minus sine x. There's our answer right there. Done. Okay. Get rid of some of this stuff because I wrote real big and used a lot of room. All right, we're working on this one. Tangent with a minus. Remember, the wall goes up on when you're proving an identity, so we can't cross over. Tangent with a minus, so that's tangent of the first minus tangent of the second over 1 plus tangent of the first tangent of the second. Tangent of pi over 2, well, that's sine of pi over 2 over cosine of pi over 2. Now here's the problem. That doesn't work. I cannot do this because sine of pi over 2 divided by cosine pi over 2 is undefined. So I got to see if I can find another way to do this. Well, I do know the tangent of anything is the sine of that thing over the cosine of that thing. And I can do that. So, sine with a minus is sine of the first, cosine of the second, minus cosine of the first, sine of the second, over cosine with a minus is cosine of the first, cosine of the second, plus sine of the first, sine of the second. Now let me stop and make sure I've got everything. Yep. Okay, sine of pi over 2 is 1. So this is cosine x, minus cosine of pi over 2 is 0. So the rest of that's gone, minus 0. Over, again, that's 0, plus sine of pi over 2 is 1. So this is cosine x over sine x, which is cotangent x. And that is what I was looking for. Okay, almost done here. We need to prove that cosine of pi over 2 minus x equals sine of x. Cosine of pi over 2 minus x, cosine with a minus, that's going to be cosine of the first, cosine of the second, plus sine of the first, sine of the second. Cosine of pi over 2 is 0, so this is 0 plus. Sine of pi over 2 is 1. So sine x, that was an easy one. That's what I was looking for. We got one more to do here. Simplify the expression below using the cosine sum and difference identities. I'm going to work on this one first. Cosine with a minus, that's going to be cosine of the first, cosine of the second, plus sine of the first, sine of the second. Now, plus, we're going to do this one. Cosine with a plus, that's going to be cosine of the first, cosine of the second, minus sine of the first, sine of the second. It's just a lot of cleaning up. Cosine of 3 pi over 2 is 0. So I have 0 plus. The sine of 3 pi over 2 is negative 1. Plus cosine of 3 pi over 2 is 0. Minus the sine of 3 pi over 2 is negative 1. So what's this give me? This gives me negative sine x plus sine x. That thing is 0. Huh. That's it. 0. Okay. This is just applying those 6 identities for sine, cosine, and tangent of a sum or difference. Answer key is posted, and we'll work on it when I get back if you're having any trouble.